Hey guys, so recently I have added more panels. So we are total up to 7 panels now, 300 watts each. So that make it about almost 2200, and they are 2 of them is in series. Each 2 is in series, and then these 3 sets is in parallels, and this last one is a single. So this one it's on a separate charge controller. I make it slanted like that so that I was hoping towards the afternoons where the sun is at an angle, this will capture more wattage, because I tend to need more power towards the afternoons. So that's why I angle the last panels separately like that, and that seemed to be working pretty good. This consistently put out about 200 to 260 watts in the afternoon, you know, between 2 o'clock to 4 o'clock. But after about 5 o'clock it completely drops off, because I have the trees right here in the back and it blocks pretty much all of the sun. So oh, and this is not my shelter, this is the shelter for the lemon tree. Does look like a shelter, doesn't it? So like I said before, the mountain, or the mountain, it's pretty crappy. So like I said, I'll try to upgrade that probably sometime next year in the winter times. So I'll probably upgrade all of the racking and go with the aluminum and metal rack instead of the 2x4, but that will do for now. So I've been playing with the angle to see which angle will give the best production for me. Hey guys, so welcome back to a update episode of my off-grid solar system. So basically a bunch of upgrades. If you watch my previous video, you'll see it's a bunch of new stuff and reposition components. So basically my total, I have 7 panels now. They are 310 watts each. So that puts out about almost 2200 watts. The biggest change would be I bought a new classic Midnite classic 150 charge controller. The reason being is that, not that the Outback doesn't work good, the Outback worked good, but not great. I did have a small issue with it where it stay after absorb, it stay in charge, and then it doesn't go to float, and it just shuts off everything. I called Outback. They said that there could be a lot of variable that could cause the issue, and sometimes that happened randomly, so they don't really know what could go wrong. They said that it's probably my solar, but it's not my solar, because after that problem there was still voltage. There was like still 78, 80 volts on my 24 volt solar panel, no, 48 volt solar. So it's not the solar. Anyway, the other reason is because I want to be able to monitor the system over the internet. And then so I bought an Outback Mate 3 so that I can use the Optic RE to monitor it, and it will send me notification that if there's a low voltage on the battery and stuff like that. So I bought the Mate 3 for another $400, hoping that it can do that. And I called them prior to purchase, asking them if it could do that. Their technician confirmed to me that it could do that. And after I bought the Mate 3, set it up, get everything working, and then it couldn't do that. It couldn't email me or notify me when there is a low voltage. I called them back and they said that, well, you need the Flex DC. Basically, that's like a voltage monitoring or system monitoring stuff. So that's like another extra $280. And I was like, no, I'm not gonna do that. So I end up, I sold the Mate 3, and I still have the Outback. I'm still trying to sell it, but I mean, if nobody's gonna buy it, I'll just keep it. So that's the end of that. So I'm not gonna tell you which controller is better. I'm just telling you why I bought the Extra Classic, and now I'm using this as my master for my big array. And then I'm only have one panel. It's that odd number, that panel 7 is on. It's going to the Outback, and you know, I figure I have the extra panel. I'll just hooked it up to the Outback. But the reason why I bought the Classic is because of the local application monitors, and then over the internet monitoring. Even though it's not going to send me the message or anything like that, but I can still monitor the system over the internet. And then it costs, the charge controller with those features costs less than the Outback itself. With the Outback, you need to get the Mate, so that's going to cost you at least $1,000 for the total. And then this one would cost you about $550 to $600. So that's why I went with that. The other thing I noticed about the Midnite Classic 150 is that it switches between mode a lot faster than the Outback. So let's say it switched between bulk MPPT and absorb or float, or go back from float to bulk MPPT a lot faster, because now I have two of them hooked up to the same battery bank. And then when it switches between, so I set the voltage, I calibrate the voltage for both controller to be pretty close, within 0.01 of a volt. But this one definitely switches a lot faster than this one. So that's pretty much that. So as you see, I rearrange it. Before I had this inverter on the top sideways, but you know, with the space being, I didn't want to rip the whole thing apart and put in a bigger panel, wood panel right here. So I had to rearrange the setup, and I think this way it looks better, and it seemed to be working better. So I have the inverter vertical now, and then added the Classic over here. So basically all I did was, I mean, the wiring is still messy, but the master array coming in right here, and then the master one go to the Classic 150. Everything's still the same. This switch cuts off everything from the battery bank, and everything still go to its own fuse. So the Classic fuse right here, the inverter fuse is right there, and then the Outback fuse is this one. All of the negative is tied into this. So, and then I added the Classic Whiz-Bang Junior to measuring the amps, what's going in and out of the battery, and also be able to use it for the ending amps on the charge controllers. So that works out good. The other thing is, you saw this, I finally got a little custom electronics plastic box. Just cut the front of it, and then I was able to put all 3 of my meters into that box nicely and neat. So this one's basically telling me how much AC is going out to the sub panels, how much I'm using at the moment, and then accumulate as well. And then this one is telling me how much is going into the battery, and that's this shunt right here. This shunt is for the Classic only, and it will only talk to the Classic. This shunt right here, the signal cables go into here. Oh, actually, this cable go up here, go around to the top, and go into this. And then here's my battery out. How much I'm taking out of the battery at the moment. So that's pretty much the biggest change. The other thing I want to talk to you about, this right here, this is my water heater relay. So in the previous video I mentioned to you guys, with an off-grid system, it's really hard to be able to utilize all of the power after your battery is fully charged. And unfortunately, I have a very small battery bank, so most of the time, 3 or 4 hours a day, my system will stay and float, and then it will only use about 70% or 60% of what my panel can do. And when I'm not home, even when I'm home, I'm having a hard time trying to find stuff to plug in because I only have actually three dedicated outlets that's going to the sub panel, because seeing this is not a grid tie system, I can't use the power throughout my whole house. So I having to add this. This is my water heater relay. So basically I'll show you the water heater in a moment here, but this is what it does. There's a 12 volt coil relay in there, and then this goes into my water heater. And so basically this go around, go into the switch, and then fuse, and then tie to the negative, and then the positive go down here, go over here, and then it goes into the positive. The signal wire from the relay, there's a signal wire that's going into my charge controller to the auxiliary channel, and the charge controller would turn on the relay when based on the state of charge of the battery. So that's what the shunts right here, the Whiz-Bang Junior, is for. It's constantly monitoring how much is going in and out of the battery and the state of charge of the battery. So once the battery went into absorb, get up to about 99%, almost full, then the charge controller would trigger the relay, turning the water heater element on. So far that seemed to be working. And then if the battery, if there's enough solar and my low will balance out, then the state of charge of the battery will stay, you know, at 99 or at 98%. And then if the battery fall, and if it doesn't have enough solar where it starts using the battery, and if it's using, let's say, 10 amps of the battery, and if it's using more than maybe 10-15 minutes, it will drag the battery down to about 97%, 96%. Then where I set it, then it will turn off the relay, turn off the water heaters. Either that, or if the water heater thermostat is hot, then the thermostat will cut the system. This relay will still be on, but the heater will be off. So that's pretty much it. So the only thing that I didn't like about my Classic, but it was a really small problem, is that the wire terminal, the main terminal, which is the PV in, the battery terminal, maximum size is only a 4 gauge. That was a minus for me, because my whole system right here is all 2 gauge. To the Outback, it's 2 gauge. When I got the Classic, the wire won't fit, so I have to go out and buy a little bit extra wire of the 4 gauge. Even though that it's a, you know, 4 gauge can do 90 amps, and that's what that charge controller maximum can do. But you know, I still want a little bit bigger wire. But so far I haven't had a problem. But that's the only minus that I could think of. Apart from, you know, you can get local application monitor over the internet monitor, and you can also remove this LCD display and then mount it somewhere else. That's another plus. So there's a lot more plus than minus. For me, the Outback didn't have that much plus and quite a bit of minus, and in order to have any of the benefit, you have to spend extra money. So that's pretty much the end of that. So now I'm going to show you how I did the water heater. Okay. Oh, and in case you were wondering what those 2 wires going up there for, that's basically the fan for my garage. I don't know if it helped much, but I guess it's better than nothing. So that's basically just two 12 volt computer fan, really big one. I think it was like 160 millimeter diameter. So it's just constantly blowing air out. of the garage, and of course the intake for the garage is on the bottom down here. So that's what those wires go up there for. So this is my new battery bank box. It's just part of a solution for me to keeping the battery cool. So here in Phoenix, Arizona, my garage typically get up to around 100 to 110, sometime 112 degrees Fahrenheit. So it is super hot for my battery. So in my last video, I mentioned that I want to keep the battery, extend the life as long as possible by not using it much. But the temperature, I think, will eventually kill my battery, even if I'm not using it. The battery was constantly, averaging about 95 to 105 every day. So I didn't think that was a good thing. So I built the battery box, and I'll show you the inside. Basically, just MDF, half-inch MDF. Try to stay as cheap as possible, and then basically just insulate it inside, and then I'll show you how I keep it cool. But let's take a look at the inside. So I cut it at a 45 degree on the side. So basically I built a rectangular box first, just a very simple all four side rectangular box. Then what I did was I draw the cuts on the side at a 45 degree, kind of a slanted 45 degree, and then basically make a cut around it completely, and then put the hinges, 3 hinges there and there, and then basically now you can basically just lift it up like this, and then the whole front would open up like that. So it's easier to get to the battery. You can take it out, put it in and out a lot easier. So it's just much more easier that way. The MDF is only about this thick, and then I fill 1 inch of the Owen Corning insulation that I had for a while, but just a 1 inch thick insulation. And then I bought some more of the foam, half-inch foam. So the insulation is about maybe 1.5 inches, 2 inch thick. And then I spray the corner with a air seal tight. So everything is pretty much air seal. So even with the box being insulated and air seal, the temperature was still was only like 5 degrees lower than before. So the box itself didn't really do anything. And the other thing is, I can vent it, have a fan blowing through it, but seeing the ambient temperature is 110, having air blowing through it is going to do anything either. So I was going to build a thermal Peltier system, those things that move the heat from one side to the other side using electric. I tried that didn't work too well. It wasn't enough, and it was inefficient. I couldn't get it to work too well. I've seen a lot of YouTube videos that people got it to work pretty good, making a little mini fridge and all that, but for me somehow it didn't work out. So my only other solution that I can think of is to refrigerate the battery, and that's exactly what I did. So I went online looking for a cheap mini fridge. So this is just like one of those 1.7 cubic mini fridge. So what I did was I bought this one online for $15 locally, and I basically removed the door. So here where the door would be. So I would completely remove the door, put it side to side of my battery bank box, drill 2 holes right here, as you see those 2 computer fan. So basically the fridge is running. This fan's gonna push the air in. This one is drawing the air out. So it runs the fridge. I set it up on a timer. I have a little timer plugged in and then plugged into the power, and basically have the fridge run in the morning 7 o'clock to like about 5 p.m. Constantly. So it's using about 110 watts to 120 watts. So I mean it's a lot more than I want it to be. I wanted to use only about 50 to 70 watts with the Peltier system, but you know, like I said, that didn't work out. Didn't work really good. So, but with the fridge now running all day long, my battery bank has been staying around, let's see, about 78 to 80 degree throughout the day. And then once it's shut off at 5, then it's going to start rising throughout the night. But the temperature, of course, go down. So at night, let's say about 3 in the morning, midnight to 3 in the morning, the highest it will go is about 88 degree, which is still better than 110. So you know, I think I can live with that. And then this will be only strictly for the 3-month hot summer here. And then in the winter time, of course, I'll shut it off and not use it in the winter time. But yeah, so that's basically just a mistake, you know, cutting the wrong hole and stuff like that. So other than that, everything looked good. And here is the battery temperature connecting to the Midnite solar. Oh, and the other thing is here's my seal. This is basically just shipping foams that I got from buying some of the solar stuff. It's just pretty much, it's a really thin, it's like maybe 1/8 styro foam. So I just cut it out and then use double-sided tape and stick it down here. And then when I close the lid, that actually get compressed onto the foams, and it provide a pretty good seal for the battery box. So just trying to keep everything cheap. So I built the whole box, probably, you know, cost less than maybe, you know, 30 bucks if you count the installation. The MDF I got really cheap because I bought the one that's broken. If you can find the broken stuff from Home Depot, they'll sell you it to you for, you know, 50% off. So here you go. Once again, this is how the lid closed. Lift it down and it's cooked. See, as you can hear the noise, it will seal pretty good. So there you go, an airtight battery box. So I know some of you is probably going to say, well, it needs ventilation. No, it doesn't. These are AG. Okay, so though that wire that I showed you earlier goes over here, come to this mini electric water heaters. So as you see over here, I have a gas water heater. Unfortunately, my house have gas water heater, and it's still in pretty good condition. So there's no reason or any benefit if I should replace the whole thing with electric. But obviously, if I would have done that, it would have been a lot easier, a cleaner system. But I mean, I don't want to replace the whole thing, and not knowing that how well, if this is going to work or not. So basically, if you have an electric one, you have 2 elements, one on the top, one on the bottom right here, and then one will be on the top. And then if you were to do solar, electric solar modification, you will leave the top one using the grid, and then you will change the bottom one to a DC element, so that during the daytime the bottom will heat up and the hot water from the bottom will rise to the top. And if it's hot enough, your top element's it's not going to kick on, so you'll be able to save electricity that way. And then if there's no solar and at the top water is cold, then your grid's going to kick on and warm it up. But for my case, I want to leave the gas for now, but I wish I could have go with the completely full-size electric one and then cancel the gas completely. But for now, this have to do. So I bought this mini water heater, 22 gallons. locally, but online. So basically, I got it for 70 bucks, which is pretty cheap, because if you buy a brand new one from Home Depot for a 20 gallons, they want at least $300. And then for a full size one, a 40 gallon or 50 gallon, it's like another extra 50 bucks. So it's a no-brainer. I'm not gonna buy a new 20 gallons for 300 bucks. So I got a used one. It's still in pretty good condition. It does have a lot of mineral built up because we're here in Arizona and the water have a really high mineral and all the rocks and calcium and all that stuff. I don't even know much about it, but anyway. So I had to spend a lot of time cleaning the inside, then replacing the relief valve, safety thing. I mean, I didn't have to, but the other one, the old one, was kind of in a rough shape, so I figured, you know, replace it, you know, for just mine as well. It's kind of expensive, $18 for that relief valve. So basically, for the plumbing side, it's really easy. You just take your coal line that's going to your main water heater. Here's the coal line. You take that, right? Instead of feeding it into your master water heater, you feed it into your preheat tank, my small tank. Coal goes in, and here's the hot one. Hot comes out the tops. And then the hot one will basically go back into the coal on the big water heater tank. And then you will leave the hot water coming out of your big tank going to your house. So that stay the same. So the only thing you take is your coal water, feed it into the small tank, and then from this hot water from the small tank into the coal on the big tank. That's all you have to do. The other thing is you have to make a T joint for the relief valve where it's, you know, go exit outside your home. So I just put a T joint and then connect the relief valve. This one goes in, and then that's where it goes to, this connection right there. So that's all there is to it. And then go online and buy a DC element, and then just replace the element inside here. Now you can still use your regular thermostat. That's what it came in there, and I used that for a few days, and I think that rather worked pretty well. But I keep reading online that those can't handle the amperage, so they're only rated for about 15 to 20 amps because 110 volt. And if you're using only on a 24 volt system, I'm pulling right now about 25 amps. So I mean, I used it and it was getting hot, but it was still working. So I don't know how long it will last. But anyway, so I end up replacing it with a DC thermostat. First I replaced it with one with 140 degree shut off from Missouri Wind and Solar. But somehow that didn't work too well. It shuts off when the water in the tank was only about 105 to 110, even though it's rated for 140. And I think the reason why it's not because the tank is getting hot, it's because the thermostat itself was getting hot because 25 amps was floating through it, causing it to heat up itself, and then it shuts off. So I bought another one at 160 degrees, and so far my solar hasn't been running long enough for the tank to get up to 160. But let me tell you what, the water tanks works, because I'll show you right here. You see that? My master gas water heater knob is on vacation. And it has been on vacation for probably more than a week now. And I'm not on vacation, I'm still at home, and we have 3 people, 3 adults and 1 kid. We don't use that much of hot water, but obviously shower twice a day for 3 people, and it seemed to be working. So my solar is able to run on a good day. is able to run the smaller tank for about 2.5 to 3 hours, and on a bad day about 1.5 to 2 hours. Now, I've been reading online before I did this system, so I was really skeptic about it because people said that it's not efficient to heat water using electricity. A lot of people go with the solar, direct sun solar hot water, but for me, this system is super efficient. The reason why being is that I have solar panel already. I have an off-grid solar panel that's overproducing when I'm not using, so I just happen to put it in here. And for me, they said that it takes, let's see, 2.5 watts to heat 1 gallon of water per an hour. Is it up 1 degree? That's crazy. So it takes 2.5 watts to heat 1 gallon of water. Takes an hour to heat 1 gallon of water up 1 degree, 1 Fahrenheit. That's crazy, but I don't think that's, maybe, I don't know if that's true or not, but only takes 3 hours to heat my 22 gallons up to about 110. And I guess it's because my garage is super hot in here. I mean, it's 110 ambient in here, so I don't know. But my water now with the new thermostat, it can get up to about 130, 135. So that seemed to be hot enough for me, so worked out well. We'll see how much extra I can save in the winter times. So basically in the winter time, what's gonna happen is I will be not using my air conditioner, because right now my air conditioner, my 6,000 BTU consume most of the power throughout the day, 8 hours a day. In the winter time, if that's being off, I can have my water heater running 8 hours a day, and 8 hours a day I think it's gonna stay hot, really hot. So far it's been working well for me. So if you have any question, just leave me a comment, and then I will answer you as soon as I can. And thanks for watching, and please subscribe if you want to see more stuff. I'll be adding to my system pretty soon. So stay safe and enjoy the sun power.